Okay, so this problem now we're going to do it without the picture. So the first thing is we're going to find the approximation, and remember that n is equal to 4. Okay, so since on the last problem I already did left, middle, and right, in this one I don't want to spend too much time on the difference between them, but we'll write all of them out. Okay, the first thing that I need is I need to find delta x. Okay, so remember that delta x is equal to b minus a over n. Now a and b, so these guys are a and b. A is 2. Let's write this down. A is equal to 2. B is equal to 6. So this is going to be, and n is equal to 4, so delta x is going to equal 1. Okay, now let's take a look at the difference between, so we're going to do the left, middle, and then the right. But we're going to go through it a little bit quicker this time. So remember what it is you're going to add up the different rectangles, and the way you find the rectangle is the base is delta x, the height is the value of the function at the x value. Now for the left, I'm just going to write a list of my x values. For the left, remember you start off with a is your first x value. The next x value is a plus, you tack on another delta x, which in this case is 2, so your next x value is going to equal 3. And then the next x value is going to be one more delta x from that, which is going to be 4. And the next and last x value is going to be one more from that, which is 5. So notice that for the left, we start at x equals 0, x sub 0, and end at x sub 3, which is 1 less than what n equals. Okay, now for the, let's do the right. Remember, for the right, you start off at what we call x sub 1, which is not at the left endpoint, but a delta x past it. So in this case, 2 plus another delta x is going to be 3. And then each one, the next one is going to be just delta x away from it. So the next one's going to be at 4. The next one's going to be at 5. And then x sub 4, this guy's going to be at 6. Okay. Now for the middle, remember we call this guy x sub I star, and this one is right between in the middle of your first two values. So if delta x is equal to 1, then your first x sub I star is going to be whatever half of this is. So this is going to be your left endpoint plus 1/2 of delta x, which is 1. That's how we find it. So this is going to be 5/2. And then the next one, x sub 2, is going to be another delta x from that. So that's going to be 7/2. X sub 3 is going to be 9/2. And x sub 4, sorry, these are all starred. X sub 4 started is going to be 11/2. Okay, now that's how you find the x values. Now, these give us where we evaluate the function, and so then the function is this guy. Well, here to find the value of the function, which is going to be the height of the rectangle, well, this is just going to be f at 2. Well, I need to plug in 2 into my function. So if I plug in 2, I'm going to get 2 cubed, which is 8, plus another 8, so that's 16. So this is going to be 17. And f of 3 is 46. F of 4, if I plug in 4 into the function, I would get 97. And f of 5 is equal to 176. Okay, and then remember that what I do is I just grab each one. These represent the height, multiply by the base, which is delta x, and I get the area underneath the curve. So this would be 17 times 1 plus 46 times 1 plus 97 times 1. It's not 0.1. Plus 176 times 1. Well, if I add up all of these guys, I would get 336 as my area, using the left endpoints. Okay, so that's for the left one, and then for the right, we would do exactly the same thing, except that now we're evaluating at these different points. So here I would use find the value of the function at 3 is equal to 46. At 4, it's equal to 97. At 5 is equal to 176, and at 6 is equal to 289. And the same exact thing, if I add up all of those, I would get 568. And I'll let you guys do the middle one, but it's essentially the same thing, except that we have fractions, so it's a little bit more annoying to calculate that. Okay, now let's get to the good stuff. Let's try to find the exact area underneath the curve using the definition. Okay, so remember what we need is we need to find expressions for everything. So remember that we need delta x, and the key is that you don't use n equals 4. So we know that a is equal to 2 and b is equal to 6. That's not going to change. But we don't give a value for n because n is going to be a variable. That's going to represent the number of rectangles. So delta x is going to be 6 minus 2 over n, which is 4 over n. 4 over n. Okay, so I have delta x. Then I also, this part is also very, very important, is I need to find an expression for x sub I. Now, x sub I, remember, is a plus I times delta x. Well, I know a is 2 plus I times delta x is 4 over n. Okay, and then I need to also find f of x sub I. Well, f of x sub I is when I get it when I plug in this guy into my function. So here what I'm going to have is 2 plus 4i over n cubed plus 2 plus 4i over n squared plus 1. Okay, so I just realized that I missed a 2 right here. Ay, ay, ay. And that throws everything off. So let me put it back in. Now, if I put in the 2, what I would get, and if I simplify all this stuff, this is a lot of algebra. But if I simplify all this stuff, what I would get is 17 plus 80i over n plus 128i squared over n squared plus 64i cubed over n cubed. Okay, now, so then what I have is I'm looking for, I want to find the limit as n goes to infinity of the sum. So I have f of x of I have delta x is 4 over n. So then I can say that the integral between 2 and 6 of x cubed plus 2x squared plus 1 dx, this is going to equal to the limit as n goes to infinity of the sum from 1 to n of f of x sub I, which is all this stuff that I have right here, everything right here. So 17 plus 80 over ni plus 128 over n squared I squared plus 64 over n cubed I cubed times 4 over n. Sorry about that, I ran out of room. Okay, now let me get a new sheet of paper and I'm going to calculate this sum. Okay, so what I'm going to do first off is I'm going to, this 4 over n, remember we did it in the last problem, this guy is a constant, so I can take it out of the sum altogether. So I'm going to take that out of the sum, and then also what I'm going to do is I'm going to break up the sum into a bunch of small sums with each one of these. And so then what I'm going to have is the limit as n goes to infinity of the 4 over n is going to be on the outside. And then I'm going to have the sum 1 to n of 17 plus, now if you take a look at this guy, let me bring it back real quick. I'll just put it right here for now. The sum of this guy, notice that this guy right here is also a constant for this sum. So I can take this 80 over n outside of this sum and just have the sum from 1 to n of I. So I'm breaking it up, so I'm kind of doing two steps at once. I'm breaking it up into little sums, and then I'm also, each one of these pieces has a constant part, almost all of them. And so this guy, I'm also going to take out the 128 over n squared, now times the sum from 1 to n of I squared, and then plus, this one also has a constant part, 64 over n cubed times the sum 1 to n of I cubed. Okay, now, then what I know is that, well, I have my my formulas. See, I know what this guy is based on my formulas. This guy is just 17 times n, because 17 is a constant. This guy is n times n plus 1 over 2. This guy is n times n plus 1, 2n plus 1 over 6. And this guy is going to be n times n plus 1 over 2, the whole thing squared. Okay, now let's do some simplification here. This is going to equal to the limit as n goes to infinity of 4 over n times 17n plus here these guys, the 80 and the 2, simplify to 40. So I'm going to have 40 n squared over n plus 40 n over n. Okay. And then plus, well, here notice that this n is going to cancel with one of these. And so that saves me some work. So what I'm going to have is 128 times, here if I distribute everything, I'm going to have 2n squared plus 3n plus 1 over 6n. And plus this n cancels with one of these, so I'm left with 2, and then the 64 and the, actually this is 2 squared, so this is 64 and 4. Why don't I rewrite this guy? This is going to be, this will make it easier. This is going to be n squared times n plus 1 squared over 4. Okay, so this 4 cancels with this guy, and I'm left with 16 on top. And then this, sorry, I messed this up. But 2 of these cancel with these 2, so I'm left with 16 over n. And I have n plus 1 squared here. Okay, so now let's take a look at the situation with the n's. This 4 over n is going to get distributed, but why don't we just take a look at distributing the n. So if I distribute this n, this would put an n on the denominator of each one of these. And so what's going to happen is, here the n's are going to cancel. These 2 are going to cancel. These 2 are going to cancel. And then these guys, well, let's rewrite this. This is going to be 128 times 2 over 6. So this is going to be 128 over 3 plus, now the n squared is going to cancel with the 2 n's down here, so there's none left. Here we're going to have 128, so the 3 and the 6 cancel. So this is going to be 54 over n plus, let's just leave it as 128 over 6 n squared. Okay, plus, here we're going to get 16 n squared over n squared, well that's just 16, plus, if we distribute all this out, we're going to get, and when we multiply 16 times everything, not n plus 1 squared, but what it equals, so let's just write it out right here. This guy is n squared plus 2n plus 1. So this is going to be plus 32 over n plus 16 over n squared. Okay, now taking the limit to infinity though, what's going to happen is each one of these with an n in the denominator is going to be going to 0. So this guy's going to 0. All these guys are going to 0. And so in the end, what I'm left with, as n goes to infinity, is 4 times 17 plus 40 plus 128 over 3 plus 16. And all of this is equal to, so that's that guy. Calculus and figure out what happens. So what we have is to find the integral from 2 to 6 of x cubed plus 2x squared plus 1 dx. This is equal to, remember the fundamental theorem of calculus, what it says is find the antiderivative, which is x to the 4th over 4 plus 2x cubed over 3 plus x. And then evaluate it from 2 to 6, doing the top, remember always top minus the bottom. So this is going to be, I'm going to plug in 6, and then, so 2 times 6 cubed over 3 plus 6, and then minus, now I'm going to plug in 2, so this is going to be 2 to the 4th over 4 plus 2 times 2 cubed over 3 plus 2. And so this is equal to 474 minus 34 over 3, which is equal to 1388 over 3.